Okay, in this exercise, we are going to do a mutational analysis using the feature exact test to determine what are the mutations in the pancreatic cancer that might be associated with the gemcitabine response. So to do that, well, we go to the mutation data that we have downloaded previously, and the first thing you need to do is basically to match all those cases with the gemcitabine response. So as I have shown you previously, so you need to convert this barcode to the barcode format that is similar to the clinical data set. So to do that, I'm going to convert this into to remove the last barcode basically. So that will be using the dash. So now each of it are in individual column, and I'm going to combine them together. So this would be, and then a dash, and this and then a dash, and finally here. So now you can see that, okay, so this barcode here is now compatible with the clinical dataset barcode that we have. Okay, so the next thing is we are going to match it, so using the VLOOKUP function. Okay, then we select the table here, return column number 2 and false. Okay, so now I will copy this into the same, but then return column number 3. Okay, scroll it down. So now we have matched the cases with the clinical response from the clinical data set. So next, I'm going to create a few rows so that to match the basically to match the cases with the response. So this would be treatment, and then this will be class, and then I will create another row called response. So basically, I'm just going to copy the whole data set here, then transpose, and then you can transpose this. So at this point, you can actually save it as a draft now. Okay. So it's good to set it at this step so that while, because following from here, that will take a lot of the resources to do the analysis, and sometimes the Excel might hang basically. So, okay, so what is going to do next is we are going to do the sorting. Okay, from left to right using row number 2. Okay, so that it will sort the whole data set. Oh, so you see that while when you do the sorting, sometimes, well, the Excel will actually hang. So, okay, but in this case here, I think they're not too bad. So, what I'm going to do here is I'm going to move back this, the gene names back to the first column. Okay, I'm going to remove this column here. Okay, so now the next step, we are going to remove those that are not treated, those data that are not treated with gemcitabine, which we do not need to include them into the analysis. I'm going to delete all this column here. Okay, once you have removed all the data that's not relevant, you will get something like this. So the treatment now consists of those cases that are treated with gemcitabine or gemsar only. So the next thing is I'm going to sort the response. Okay, so basically I'm going to select the data set range here, and I'm going to sort it again. So left to right, and then this time I'm going to sort it by row number 3 here. So okay, clinical progressive disease, we will classify them in not as non-responder. Responder. So these are all clinical progression. And then we have a complete response, which is considered as responder. Response. And then we have a lot of it, which is unknown here, basically. And then, so we might also want to remove this from our data set. So, and then you have partial response and stable disease. So partial response will consider as responder, and stable disease considered as non-responder. Okay, so then after that we will do another round of sorting, this time sort with row number 4. Okay, so now you have the, oops, so I will select the range again, and then I will sort it based on the row number 4 here. Okay, so now you have the non-responder over this side, and then responder all over this side. Okay, let's save this. Next, what we are going to do is perform the Fisher exact test for this data set. There are a lot of online Fisher exact test calculator, but none of it most of it can use to test one hypothesis at a time. But to apply to a data set like this, which have about like 39,000 entry. So what we are going to do is we are going to download add-ins for the Fisher exact test for Excel. So there is a very useful add-in. You can go to this web page here. So to download the Excel add-in, basically what you need to do is you just follow the instruction to install it, and then it have all the instruction to teach you okay how to set it up. So for instance, in this case here, I have already downloaded this add-in into the download folder. So what I'm going to do now, I'm just going to go to here and then options, and then go into add-ins here. Then you can choose okay which one you want to add in. So in this case here, I already included, well, I have already have this add-in loaded to the Excel. If you are not sure how to do that, you can go to here, manage Excel add-in. So you can browse, and then you can actually select where the location of your add-in in this case here is actually I downloaded here in this folder here. I'm just going to include that in. So do you want to replace it? Yes. So once you have that done, then after a while, then you will have the add-in into the Excel file. So next, what I'm going to do is I'm going to follow the instruction as to how to classify and calculate each of the columns here. Basically, now here I'm going to create a few more columns. Basically, this will be a responder. Okay, column, and then if there is mutation and no mutation, and similarly, okay, I will have another column here which is the non-responder. Okay, so all you need to do here is basically you sum up all the mutations cases for the responder, so which will be from here to here. Okay, and then the no mutation is basically the total number minus your mutation cases. In this case here, we can calculate this basically. So in this case here, you have basically 18 non-responder and 21 responder. So I'm going to, so responder is, oops, responder is 21. Responder is n equals to 21, and non-responder is 18. N equals to 18. So it's the no mutation is basically 21 uh, minus this guys here. Similarly, I'm going to sum up all the mutation for non-responder, which is until here, and then the no mutation is equal to 18 minus this. Okay, so once you do that, then you're going to copy it all the way down here. So to make the performance faster, I'm just going to copy and paste it as values instead of the formula. Okay, so now then you can perform your Fisher exact test p-value. So how are you going to do that? You refer to the home page here. Okay, you can do basically so just to insert this formula here, and then we are going to do one depends on whether you want to do a one-tail or the two-tail test. So in this case here, basically we are going to do a one-tail test and see whether, well, actually we should do a two-tail test first to see whether it is actually significantly associated or not. So to do that, I'm going to now FET. Okay, so that will be this, 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 and then 1. Okay, so is that correct? Okay, oh, true option flag for one or two tail. So true is equals to one tail. Okay, I think we can ignore the flag here. Okay, so let me copy this down all the way. Okay, so now you have your p-value of the Fisher exact test here, basically. So again, I'm going to copy this down, and then I'm going to paste it as value. So now let me, so you can save this at this point. Now let me just sort it and see what are the genes that are the most significantly associated. Okay, so in this case here, if you use the p-value, okay, of 0.05, there's only one gene that is highly associated with the gemcitabine response, which is CEL-SR3. And when we look back to this data here, basically what it suggests is that if you have some mutation here, well, the patients are not going to be respond to this. So now you will see that, okay, in this case here, you only have one hit, so and the rest of it are basically not really that statistically significant. So that is fine. So I mean, in this is basically a type of statistical test to evaluate the association of a single gene to the response. So in many cases, okay, in this case here, there's one gene turned out to be significantly associated. So it doesn't matter because always bear in mind is that in the Fisher exact test, it is basically testing the association of one gene with phenotype, in this case here, respond and non-responder, one gene at a time. So, but in reality, basically, there could be many mutations that could contribute to the same phenotype. So that's therefore, if you use a statistical test, so in this case here, you only, well, it is quite understandable why you only get one or few genes that is associated. So, however, if you want to look at the whole data set, well, you might, and also do some machine learning algorithm, you might be able to see certain pattern, okay, that might be associated. But as far as the Fisher exact test here, I think we only get one hit here, which is basically this CEL-SR3 genes, which might be associated with the response. So that's it for this session. Thank you.